Hello everybody, it's Mr. Ray here. I hope you're having a good day. We're going to continue on with our grade 10 applied math course. We're going to start a unit entitled linear equations. Linear equations is actually a very important skill that you'll need in grade 11 and 12. And I'm going to attempt to teach you some methods that hopefully make sense, that allow you to continue solving equations of a more difficult level once you get into higher grades in school. So I'm going to start off with a few definitions. Okay, so an equation, if you remember the video we did at the beginning of the course on math as a language, we talked about things like terms and expressions and variables and constants. The last thing I think we talked about was an equation. An equation, it's very easy to determine if something's an equation because it has an equal sign in between two math expressions. Okay, and by expressions, it could be as simple as something like x equals 2, or it could be something much more complicated, which we'll see. Easy to identify, and the thing we do with equations is we solve them. The verb we use with equations is always solve. Solving has a very important meaning. It means, if we look at the definition here, solve an equation means we find the value of the variable that makes the equation true. So the equation, if we go back to what it might look like I said, the equal sign in the middle, it's going to be using one variable or letter. Usually that's going to be x, but it could be any letter. You may find that letter is used more than once. You might have an x on both sides, but the goal is still the same. What's the value of x that makes this thing true? And pretty much 99% of the cases, you're going to see that there is a solution, and there's only one solution. So I don't think we'll have any examples in this course, this unit, where there isn't just a single solution. So that should make it a little more straightforward, I think. Once you get to more difficult equations next year, you'll see that, well, maybe you have, maybe you have two solutions, maybe you have none, maybe you have one. Okay, so it gets a little more complicated. But for this year, it's always going to be one solution, which means there's only one value of x, or whatever variable we use, that makes the equation true. This is a very important definition. It's pretty much always the first question or a question on any test I do in this unit. Just to make sure you understand. And that's going to be true. This definition will hold for any type of equation. We're only looking at linear equations in grade 10. Like I said, once you start doing other equations, this definition still passes the test. It still means the same thing. Okay, now there's going to be a few concepts, a few ideas I want to teach you about how to think of an equation. But the tools we use to solve equations is all based around what we call opposite operations. Another word for opposite operations would be inverse operations. It means two types of math operations that are opposite, that undo each other's. For example, if adding and subtracting, those are opposite or inverse operations. If I add 2 to a number, then I subtract 2, I'm back to where I started. So subtracting 2 in that case undoes adding 2. And we also have other types of opposite operations. Adding, subtracting, and multiplying, dividing are also opposite, and those are pretty much the only ones we're going to need to use in grade 10. So always think about how do I undo what's being done, and we'll get to something more concrete on that later. Okay, you might also hear the expression isolate a variable. So if you think about what isolate means, it means by itself. Isolating means get something by itself. So isolating a variable means we want to get the variable all by itself on usually the left side of the equation, and then on the other side of the equation we'll have a number. So we'll have something, maybe when we isolate the variable we get something like x equals 4. Okay. Now by isolating the variable we've also actually solved the equation. We've figured out the value of x that makes it true. So solving an equation and isolating a variable basically have the same ending. We end up with something like this. Okay. All right. Now, I've got this beautiful diagram down here. I'm gonna zoom in it. I'd like to talk about what we've got here. So if you look at the main picture here without the little labels, we've got one of these old-fashioned looking scales. It's got it's got a left tray that's hanging from this arm, a right tray hanging from this arm. This is the same arm. And if we use this to weigh things. In the old-fashioned days, we'd put something on this tray that we want to weigh. Then we put some predefined weights on the other side. And what we want to have happen is the two trays are level. They're, the scale is balanced. Okay, and when that happens, that tells us that this unknown package over here, whatever we're trying to weigh, has the exact same weight as what's in this tray. So that's what they used these trays before, but it's actually a very good analogy to equations. So when you have this scale, you've got a left tray and a right tray. When we have equations, for example, if we had the equation 3x plus 1 equals 16, I could kind of bring this equation down to the scale. As on the left side of the equation I put into the left tray, and the right side of the equation 16 I put into the right tray. Now the fact that it says an equation equals means that at that moment, right now, these two trays are balanced, which means they have the same value or the same weight in terms of what scales are used for. Now if I want to do anything to this equation or this scale, here's the most important rule. If I take away anything from this side, you can imagine the tray, all of a sudden this side now becomes lighter than this side, so the trays will tip up and they're no longer balanced. If they're not balanced, then they're no longer, the equation's not equal. So that tells me that anytime I do one thing to one side of the equation or tray, I have to do the exact same thing to the other side. Otherwise, the scale or equation won't be balanced. So I can do a number of things. In terms of math, I can add something to both sides. I could add 4 to both sides, still balanced. I can take away 10, still balanced. I can multiply both sides. For example, multiply both sides by 2, it's like doubling. Okay, and if I do that to both sides, it's still balanced. Or I could maybe divide it by something, divide both sides by 3. And basically, it's still going to be balanced. So we have to keep that in mind as our golden rule for solving equations. Anytime I'm solving an equation, I have to do the same thing to both sides of the equation. And we'll talk about how we solve it, but that's the main key to how we solve an equation. Okay, so I've kind of talked about this here. The best way to think of solving an equation is compare it to a scale with trays. See the picture below. The left tray is the left side of the equation, the right tray is the right side of the equation, and the equal sign in the middle means the two trays are balanced. Okay, as soon as it's not balanced, they're no longer equal. But when you start off with an equation, they are equal, and it's our job to make sure that it keeps on being equal. Okay, and then this kind of repeats what I just said. Since an equation is like a scale, the most important rule is that whatever you do to one side of the equation, you must do the same thing to the other side of the equation. If you don't do the same thing to both sides, the trays won't be balanced anymore, and the equation won't be equal anymore. Okay, talked about that. Now, here's an important thing about solving equations, and it's kind of a bad habit that a lot of teachers um, give math students in usually elementary, middle school, and sometimes grade 9, is using the word or the verb move. And I hear lots of students, when we're solving equations, they say things like, I'm going to move the 2 to the other side. For example, they might say, I'm going to move the 1 to the other side. Well, using that language tells me I'm removing 1 from this side and I'm placing it over here. If you think about the scale, if I remove the 1 and then move it over here, well, that's not going to be balanced anymore. I didn't do the same thing to both sides. Okay, so please avoid using the word move. I want you to use words like, I'm going to add something to both sides, or I'm going to subtract something from both sides, or I'm going to multiply both sides, or divide both sides by some number. Okay, that's the communication, the sentences that I want you to be using when you talk about solving an equation. Okay, now we'll get into the actual mechanism of solving. You've kind of got the main ideas about the rules. Now, once you solve an equation, like we talked about here, we get something like the variable, in this case x, is equal to a number. That's our solution. Okay, well, how do you know that that's right? So, the best way to check a solution to an equation is to substitute the solution into the original equation. And then you figure out what the left side is equal to, what the right side is equal to, and hopefully both sides are the same. If they are the same, that means your answer was correct. If the two sides are different, that means something went wrong. Probably you have the wrong value. Maybe your check was wrong. So, for example, for this one here, 3x plus 1 equals 16. We talked about how we have the different trays. If I solve this and well, say I got the answer x equals 5. Okay. The thing about solving equations is you can always check your answer. Now I never feel 100% confident until I check the answer. I might be pretty confident about what I did, but until I actually check the answer, I'm not 100% certain. So the way you do that, say I got the answer x equals 5, or the solution x equals 5. The way we check that is I say, okay, if x equals 5, this side here would be 3 times 5, which is 15, plus 1 is 16. Okay, and then I go over to the other side. Well, it's just the number 16. So if x is equal to 5, the left side 16, the right side 16, that is definitely true. 16 equals 16, and I know my answer of x equals 5 is correct. If I got some other answer, say I got x equals 2, if I plug x equals 2 into the left side, I get 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So I get 7 on the left side, 16 on the right side. 7 does not equal 16, so therefore the solution I plugged in was incorrect. Okay, so that's the way we check our answers, and there'll be some examples on doing that later on in this lesson. Okay, now I'm dividing solving equations for the course into 2 lessons. So the first lesson, if you remember the name, it's 1 and 2 step equations. So what does that mean? It means if it's a 1-step equation, I really only have to do one thing and I'm done. Okay, so 1 step is quick. Well, just one, I'm going to do something to both sides and I'm done. Okay, sometimes it's going to be a 2-step equation where you have to do 2 separate things to both sides and you end up with your solution. So that's what we're going to cover today. Now, unfortunately, not all equations are 1 or 2 steps. Sometimes it's more complicated, and that's what we'll be looking at in the next lesson, lesson 2. And I have a very lovely step-by-step approach to basically solving any type of equation. But for today's lesson, we're just looking at 1 and 2 steps. Okay, so the first page here